Hello everyone, this is Nandini Joshi from MTech 2K20 batch of IIPS DAVV Indore, and this video is a part of my analysis and design of algorithms assignment. In this video, we will be reviewing the second internal question paper, which is an MCQ based paper. The first question here is, what is an algorithm? So algorithm can be considered as a set of instructions to perform a task. So here the correct option is option A. The second question is, which notation is commonly used to represent the time complexity of the algorithm? So here the correct option is option D, which is all of the above. All of the above asymptotic notations can be considered as the correct way to represent the time complexity of any algorithm. Question number third. What is the purpose of analyzing algorithms? So why do we analyze an algorithm? So algorithms are analyzed so that their performance can be optimized, their time complexity, their space complexity, or their power complexity. These are the measures of a performance of an algorithm. So to optimize the performance of any algorithm, we use uh, so to analyze algorithms, we use such kind of asymptotic notations. The fourth question is, which of the following is an example of a dynamic programming problem? Dynamic programming problem is considered as a way to analyze algorithms in which we divide an algorithm, we find a recursive solution for that algorithm, and then find the optimal solution. So in these four options here, the longest common subsequence problem can be considered as an example of a dynamic programming problem. Question number fifth. Which of the following is an example of a graph algorithm? Here the correct option can be option number C, depth first search. In this depth first search algorithm, we traversed through a tree by traversing throughout the layers of a tree and reading all its left and right child and then going to their child. That means first we will read the parent node, we will clear one complete level, and then we will move on to the next level. So so the next question is question number 6. What is the time complexity of binary search? So the correct option here can be option number D, order of log n. Order of log n can be considered as the correct time complexity measure for the binary search algorithm, in which we divide the whole problem into two parts and then search for a specific element in an array. The question number 7 is, what is the time complexity of merge sort algorithm? So merge sort algorithm time complexity can be calculated using n log n, order of n log n time. Its complexity can be calculated in that amount of time. In merge sort algorithm, we divide the whole array into equal parts and then we sort it, and by sorting it we combine or merge the array into one final sorted array. So this type takes n log n time. Why? Because merging the algorithm will take log n time complexity, and traversing through the array, which consists of n number of elements, will take order of n time. So for each element, if we repeat the same process, then it will then this whole algorithm will take order of n log n time. Question number 8 is, what is the time complexity of quicksort in the worst case? So to first understand what is the worst case of quicksort algorithm, quicksort is we take a pivot element and then using that pivot element we sort the whole array and complete each iterations. So the worst case can be either the pivot element can be either the largest element of the array or the smallest element of the array. Or the worst case can be if the given array is already sorted. See, the machine doesn't know that the array is sorted or not. So that is the problem in quicksort worst case, that if we provide an already sorted array, then also it will perform the same algorithm for that array, and it will generate a time complexity, and for that case the time complexity will be order of n square, that is n to the power 2. So here the correct option for question number 8 is option D, order of n square. Question number 9. Which of the following is an example of a divide and conquer algorithm? Divide and conquer algorithms are like divide and rule policies. Like we divide a whole problem into sub problems, and then we apply the algorithm on the sub problems and then combine the whole problem into one complete solution. So divide and conquer algorithm strategy can be used in binary search algorithm. So here the correct option is option number A, binary search algorithm. Question 10th. What is the divide and conquer strategy? We just now saw that what is the divide and conquer strategy. So divide and conquer strategy is that breaking a problem down into smaller sub problems and solving each sub problem recursively. So the correct option here is option number A. Question number 11. Which of the following is an example of a greedy algorithm? Greedy algorithm is that like we search for the most minimal or most optimal solution which is given to us in the recent case. We select a optimal solution presently and then move forward and then select another optimal solution for that. That means we move forward by selecting more optimal and minimal solutions to minimize the cost or to maximize the profit. So here the example of a greedy algorithm is option number C, Huffman coding algorithm, in which we use this greedy technique to find the compression of to compress a encoded file or to compress a whole written file which is of which can be of great that means which can be of a large size. Question number 12. What is the time complexity of Huffman coding algorithm? So the time complexity of Huffman coding algorithm is order of n log n. So here the correct option is option D, order of n log n. Question number 13. Which of the following is an example of a dynamic programming problem? A dynamic programming problem, just now we learned that what can be considered as a dynamic programming problem, that is we search for a recursive solution and then we generate an optimal result. So a recursive solution can be generated in the matrix chain multiplication problem. So here the correct option is option B, matrix chain multiplication. Question 14th. What is the time complexity of breadth first search algorithm? So the time complexity of breadth first search algorithm is order of n. That is the correct option is option A. Question number 15. Which of the following is an example of a graph algorithm? That's the same question. So here the graph problem is breadth first search, and we just now learnt about another graph problem or graph algorithm which is depth first search. So breadth first search and depth first search are both two types of techniques which we use to traverse through a tree and search for a specific element. Both are done in different ways, that's why both have different time complexities, but both are graph algorithms. So here the correct option for question number 15th is option C, breadth first search. Question 16th. Which notation is commonly used to represent the space complexity of an algorithm? The space complexity of an algorithm can be easily represented using order of 1. So here the correct option is option D. Question 17th. Which of the following is an example of a divide and conquer algorithm. Divide and conquer algorithm can be easily done in minimum spanning tree algorithm. So here the correct option is option B, minimum spanning tree. Question 18th. What is the time complexity of matrix chain multiplication problem? Matrix chain multiplication problem is a problem in which we find a sequence of parentheses to join on the chain of matrix such that the number of scalar multiplications are minimized or reduced. So it is a technique to parenthesize the sequence of matrices. So here its time complexity is order of n cube, that is n to the power 3. So the correct option is option D, order of n cube. Question number 19th. Which of the following is an example of a greedy algorithm? Greedy algorithm can be easily done in the minimum spanning tree algorithm. So the correct option here is option B, minimum spanning tree. Question number 20. What is the time complexity of binary search in the worst case? So the worst case of binary search, the time complexity can be option D, order of log n. That is for searching the element without dividing the array, that is doing linear search. So the time complexity for binary search, or the correct option for this question is order of log n. So here we have discussed all the correct options for the 20 questions which have been given to us in the second internal paper. This was the part A of the second test. We will be discussing part 2 of the second internal exam in the next video. So thank you everyone. Thank you so much.